In this video, we're going to do some more practice questions on trig equations. We're asked to solve each equation for x in the interval where x is between 0 and 2 pi, given our answers in terms of pi. So we've got a range of questions here, and these now are being measured in radians. We can see we've got a straightforward example of a trig equation here, where we've got sine x is equal to 0. We've got an example of a compound angle here, and we've got an example of a multiple angle just here. So let's go ahead and look at some techniques that we could use. Let's take this one right here. Now with this one, what I want to do is find a principal value for the angle x plus pi by 6 and then consider subsequent solutions that will fit now into the interval where x is between 0 and 2 pi. What we can do here is now alter the interval to match the compound angle. We certainly don't have to, but it might help you out. So what we're going to say then is x plus pi by 6 will be between now, and we're going to have pi by 6, and then we're going to have 2 pi plus pi by 6. If I write that as a top-heavy fraction, that's going to give me 12 pi by 6 plus now pi by 6, which is 13 pi by 6. So as stated, altering the interval may help you out, but can get you in a little bother in terms of some messy fractions. It's entirely up to you. So what we want to do is consider now a principal value, and that is for the angle x plus pi by 6. That's going to give us now the inverse tan, so tan to the minus 1 of root 3. This is one of our special angles. If we have the inverse tan of root 3, the principal value is pi by 3. It's a 60-degree angle. If you're unsure, in a calculator, if you put this in radians mode, shift mode 4, take the inverse tan now of root 3, that will give us pi by 3. So what I'm going to state at this point now is that x plus pi by 6 is going to be equal now to pi by 3. Now at this stage I could write pi by 3. What I'm going to do instead is write 2 pi by 6. Now it might seem a little strange, but I'm looking now at having the same denominator of on these two fractions. Again, we don't need to do that, but it might help you out. Let's just consider now the tan curve. We've seen this time and time again. Tan of theta will be equal to tan of 180 plus theta, or when working in radians, pi plus theta. So what we're going to do is just add now multiples of pi. So what we have then is the solution, x plus pi by 6. The first one is going to be now equal to 2 pi by 6 plus now multiples of pi. So if we think about the next one now, we're interested in the interval between now pi by 6 and 13 pi by 6. Now 2 pi by 6 you can quite clearly see is bigger than pi by 6, and of course pi by 3 would be bigger than pi by 6. So this one fits in the interval. Let's now look at adding one lot of pi. So we got x plus pi by 6, and I'm going to add now 6 pi by 6 at this stage. So if I do that, I'm going to end up now with 8 pi by 6. And this is the advantage now of switching this up. Again, if you hadn't, you would have had 4 pi by 3, because we would have added now pi to pi by 3. I can see if I add another multiple of pi, that's going to take me to 14 pi by 6, and therefore outside the interval. So all I need to do is consider these two solutions. So if I do that, I'm going to subtract away, so let's just go ahead now and subtract away pi by 6 on the first one. So that's going to give me x is going to be equal to pi by 6, and this is in terms of pi, and then we've got now subtracting pi by 6, 7 pi by 6. So that is one approach, and that gives us now all of the solutions to the particular equation now between the interval here for x between 0 and 2 pi. You can see now if I add another multiple of pi, we're going outside the interval. Okay, say you didn't want to take this approach of switching it up. All you would have done at this stage right here is said that x plus pi by 6 is going to be equal now to pi by 3. X plus pi by 6 is going to be equal to adding another pi. We know by the nature of the tan function, the next one is going to be 4 pi by 3. The next one, we're going to have x plus pi by 6 is going to be equal to adding another one. We're going to have 7 pi by 3. We could keep adding these and then consider now subtracting away and bringing it back into the interval. This would be a slightly more uncultured approach, and again, if you went backwards, you could just have now x plus pi by 6 is going to be equal to minus 2 pi by 3. So if you had a negative interval, you could just adopt this and subtract and then see which ones fit into the interval at the end. It's entirely up to you to do that. I think this is quite nice. I personally would like to think about a solution here now to say that our solution, the general solution, is at this point right here. My general solution I can write is x is going to be equal to now pi by 6 plus pi n. So all we're doing is looking at these. So these are now going to cycle such that we have one every pi beyond pi by 6. So we can see we've got 7 pi by 6. We'd have 13 pi by 6, which quite clearly goes outside the interval for now x, and we can do it in that way. So that's a couple of different ways that you could solve that particular equation. Okay, so that now gives us an example of an exact value. This is one of our special angles, and we can write it in terms of pi. Let's look at another one. Let's choose another one. Let's go for this one right here. Let's go for cos of x plus pi by 3 is equal to minus root 3 over 2. So again, if you wanted to switch the interval up, we've got x plus pi by 3. So we could say now that the interval is going to be between 0, so let's write this here. So we're going to have 0, so that's got to be adding pi by 3 to each part of the inequality. And then I'm going to add pi by 3. Now consider that this is 6 pi by 3, so this is going to be 7 pi by 3. So if you're not happy with working with your fractions, you've got the choice of a calculator, or you can just bring them back into the interval at the end. So what we'll say then is the following. Principal value. We're looking for principal value for x plus pi by 3. And that's going to be equal to the inverse cosine now of minus root 3 over 2. Again, this is one of our special angles. If we recognise it, we can go ahead and write it down. If you're unsure, again, you can get that value on a calculator. If we look now at the unit circle or cast diagram, this gives us a special angle. Remember, cosine is negative in the second and the third quadrant. We have this angle here, and when we've got to minus root 3 over 2, this gives us an angle here, let's just write that on, of pi by 6. So we got an angle of pi by 6 just here, that angle there. We've also got one just here, so that's going to be pi by 6. Therefore, now the value of our principal value now for x plus pi by 3 is going to be 5 pi by 6. By symmetry, we can say the next one is going to be 7 pi by 6. If we just consider cosine now of theta is equal to cosine of 360 minus theta, or 2 pi minus theta. If you didn't like the idea of that, in the calculator, in radians mode, so shift mode 4 if you're not already in radians, and then what we'll do is take the inverse cosine of minus root 3, so minus root 3 over 2. That's going to give us now the 5 pi by 6, and then of course if we do now 2 pi minus that answer, then we're going to end up with a 7 pi by 6. So at this stage what we can say now is x plus pi by 3 will be equal to 5 pi by 6, and by symmetry x plus pi by 3 is going to be equal to 7 pi by 6. All subsequent solutions now are going to be 2 pi n on. Just consider the cosine function. Cos of theta is equal to cos of 360 plus theta, or 2 pi plus theta. All this is telling me now is that the cosine curve is cycling every 360 degrees, or 2 pi radians. So if we think about now the cosine curve, let's just go ahead and draw it. If we have now cos, we're going to come round, we'll come up, and this just cycles now every 2 pi radians, or 360 degrees. In the same way, it's going to go infinitely far in this direction, if you excuse the expression. So if this is going to be pi by 3, and we have another one, we're going to have one pi by 3 on, if we just add 2 pi, so let's just go there, so add 2 pi, and that would give us now, what's that going to give us? That's 7 pi by 3, and so on and so forth, and we just add multiples. Okay, so what we can state then is that this is going to be plus 2 pi n, and this would be now a solution plus 2 pi n. So any ones from here are going to simply be multiples of 2 pi on. Now if I add 2 pi, let's see what that's going to do. So if I add 2 pi now, that means that this is going to be 17 pi by 6. So if we look at that now, let's just think about 17 pi by 6. Now 17 pi by 6 is going to be bigger than 14 pi by 6. So we can see quite clearly now that the next one is not going to be valid. Therefore, all we need to do is go ahead and solve these. If we look now pi by 3, we've got pi by 3, we can see 5 pi by 6 is bigger than pi by 3, so these are the ones we want. So what I'm going to end up with is subtracting pi by 3 from here. So that's going to be now 2 pi by 6. So if I take 2 pi by 6 from 5 pi by 6, I get 3 pi by 6, which means x will be equal to pi by 2. That now is the solution right here. This one right here, I'm going to subtract that away. That's going to be now 2 pi by 6. So if I take 2 pi by 6 from 7 pi by 6, I get 5 pi by 6. At this stage, you could have just solved for this one and then said all subsequent solutions are going to be 2 pi on from there, and solve for this one, all subsequent solutions are 2 pi. But these are the two that we're interested in the given interval. So if we just think now, if I add 2 pi to this, we're going to quite clearly go outside the interval. If I add 2 pi to the next one, we do. So different ways that you could solve this, entirely up to you. Now with this one, you could just go ahead and list, again, multiples of this angle, and then bring them back into the interval at the end and see which ones fit in. So you could have said x plus pi by 3 is pi by 6, x plus pi by 3 is 7 pi by 6, and then add them on, subtract the pi by 3 away from them, and see which fit in. Sometimes with a negative interval, that might help if you're subtracting multiples of 2 pi, and then just see which ones fit in at the end. So entirely up to you, but that's now a way of solving that particular equation. Okay, let's do another one. Let's do cos 2x. So this is an example now of a multiple angle. So we've got the form, we've got the form now cos of kx or nx. We've got some multiple. So we could alter the interval. If we're interested in x between 0 and 2 pi, we're interested in 2x between 0 and 4 pi. So let's now go ahead. Principal value for the angle now 2x is going to be equal to the inverse cosine now of minus 1 over root 2. Again, this gives us one of our special angles. If you know that one, go ahead and write it down. If not, you can put it in a calculator. Looking at this on the unit circle, what we have, we know that the cosine function is going to be negative in the second and the third quadrant. This gives us a pi by 4 angle. So this would be now pi by 4. If you like, let's just go ahead and do this. So let's just put pi by 4 on here. Now, we know that if I pitch up this little right angle triangle, this is going to be 1, this is going to be 1, and this is going to give us now root 2. So we can see that the cosine of the angle is minus 1 over root 2. In the same way, I'm going to have by symmetry 1 just here. We've got 1, we've got 1, we've got root 2. So this is going to be 3 pi by 4. Just consider what we're doing. We're coming round now, and the equivalent now obtuse angle will give us 3 pi by 4. This is going to be pi, so the next one is going to be pi by 4 on, which is going to give us 5 pi by 4. If you want to look at it like that, you can do. I'm not suggesting you have to. Alternatively, if you wanted to look at the graph, you could look at the graph. So if we do that, let's go ahead, and what we'll have is something that looks like so. So here's cosine theta. We're interested now in minus 1 over root 2. We're going to have 1 there, and then we're going to have 1 there. Again, not a brilliant sketch, but that gives us some idea. So that now gives us our symmetry. This one right here is going to be 3 pi by 4. That would be a principal value. And now by symmetry, this is going to be now the 5 pi by 4. So that's what we have. So what we can write then is the following. We can write that 2x is going to be equal now to 3 pi by 4. And then by symmetry, 2x is going to be equal to 5 pi by 4. If we think about the cosine curve, all subsequent solutions are going to be now 2 pi on. So we can write plus 2 pi n. And this is one approach. So if we think about these are our first two. So what we're going to do now is list another lot out. So if we think about this now, this, let's just write this as now 16 pi by 4. So what I'm interested in is this not going outside 16 pi by 4. You can look at it again if you wish, like so. So what we have then is 2x is going to be, if I add now 2 pi to 3 pi by 4, that's going to give me, this is 8 pi over 4, so that would be giving me now 11 pi by 4. If I now added the 2 pi to 5 pi by 4, that's going to now give me what are we going to end up with on that one? We're going to end up with 13 pi by 4. So we can see now that they are the ones in the interval. So all we'd have to do at this stage now is split them. If you're unsure why you're solving this between 0 and 4 pi, just consider the cosine of 2x. If we think about the cosine of 2x, the cosine of 2x cycles twice in 360 degrees, or 2 pi radians. Therefore, we're going to have double the number of solutions we would if we had x in the interval now from 0 to 2 pi. Right, so let's just go ahead and solve these. So I can see now the first one, x is going to be equal to 3 pi by 8. We're going to have x is equal now to 5 pi by 8. We've got this one right here, x is going to be 11 pi by 8. So x is going to be 11 pi by 8. And then finally x is going to be 13 pi by 8. So x is 13 pi by 8. Okay, I personally would like to think of this now to say what we're going to have if we take this one just here. So let's just deal with this one here. I'm going to take this one and by symmetry have this one. I'm going to solve now for x. X is going to be equal to 3 pi by 8 plus now pi n. So all we're looking at are multiples of pi. We know that this curve is going to cycle every pi radians instead of every 2 pi. That's the nature of cos 2x. So x is going to be equal to 5 pi by 8, and then we're going to have plus pi n. So these now are my 2, and all I'm going to do is add and subtract, if I wanted, if the interval changed, multiples of pi. And we can see that's the case. That's one multiple of pi. That's 8 pi by 8. That is 8 pi by 8. We're just jumping up. So there we go. That's a way that you could solve that. So our values, regardless, are going to come out to be like so. But this would now be what we called a general solution for x. And we have now these general solutions, and then we can find values on from there. And again, I've done it this way. You don't have to. You can get a principal value on a calculator. If we do now the inverse cosine now of negative 1 over root 2, or the calculator would like to write root 2 over 2 as it rationalises it, that gives us 3 pi by 4. If we then said to ourselves, well, the other one by symmetry will be 2 pi minus that answer, 5 pi by 4. So if you're still not confident, you can use a calculator. All we're doing is looking at multiple ways that we can solve these equations. Okay, let's move on and look at something different. We're asked to solve each equation for theta in the interval where theta is between negative and positive 180 degrees. We need to give our answers to one decimal place where appropriate. Okay, let's choose one of these. Let's go for this one right here. 1 plus sine theta, 1 plus sine of theta plus 110 degrees is equal to 0. So this is going to give us something quite nice, but we just have to be a bit careful because we've got now this negative interval. Now if I think about the sine curve, let's just do the sine curve. When we have now the sine curve between, and we'll do this from here, that's going to be 0 to 180, that's going to be minus 180 to 0. So here's now minus 180, there is 0, there is 180. So let's think about how we could rewrite this. First I'm going to subtract 1 from both sides. So what we've got then is the sine of theta plus 110 degrees will be equal to minus 1. We could consider this interval now for theta plus 110. Theta plus 110, or I'm going to add now 110 to each part. So if I do that, I'm going to end up now with minus 70, and then we're going to have now 290 degrees. So I'm interested in this particular interval. So if you like, we could continue this round like so, and we'd see something of this nature. So what we're going to do is get a principal value right here. So what I'm going to say then is a principal value. So we've got now sine of theta plus 110 degrees is going to be minus 1. So we can say theta plus 110 will be equal to the inverse sine of minus 1. Now this is one of our special angles. So what we can do is write this theta plus 110, and this is going to give me now, just consider this point right here. This is going to give us the value here. If we looked at it graphically now of, and that's going to be the 270 degrees. Yet the calculator, if we put it in the calculator, will give us the angle just here. So if you put this in the calculator, the inverse sine of minus 1, let's go ahead. So let's put this in degrees, shift sine, so in degrees, shift sine of minus 1. Principal value now is going to be minus 90. Now let's consider what we have here. Minus 90 is not going to be in the interval. So what we would do is the following. Let's go ahead and write minus 90 degrees. So we need to consider now something that's going to be in this particular interval. So what we could do is say theta plus 110 degrees is going to be minus 90. Remember, we're going to get multiples of 360 degrees on. This is just going to cycle. So we can say 270. And again, if you wanted to add another one, you could go ahead and add another one, and it would take it outside that interval. So we can see quite clearly that we're only going to have one solution to this equation. So from here, we can, essentially what we're doing is looking at this particular interval. So we're looking at minus 70. So let's put minus 70 there, and then we're looking up to 290. So this is what we end up having, and we'll put it like so. So what we're saying to ourselves is, in this interval now, for the angle theta plus 110, where is this equal to minus 1? Now, if I drew a line now, and this is, again, one way of looking at it, certainly don't have to, we can see in this particular interval, we've only got one solution, and this is how we're going to do it, which is going to subtract away now the 110. So theta is going to be equal to 160 degrees, and that now gives us exactly what we're looking for. Now, if you wanted to check that, just plug it back into here. If I've got 160 plus 110, that's 270. The sine of 270 degrees is minus 1. Minus 1 plus 1 is 0. And that gives us now our only solution, as this one falls outside the interval. So you could argue now that altering the interval has allowed us to do that. But again, you can bring it back at the end. Okay, let's do another one. Let's choose something different. Let's go for this one. 1 minus 4 sine of 1/3 theta is equal to 0. We're interested in theta between negative and positive 180. So what I'm going to do is just rearrange this. I'm going to add now the 4 sine of 1/3 theta to both sides, and then divide by 4. So I can write this now as the sine of 1/3 theta is going to be equal to 1 over 4. So straight away we can see this isn't one of our special angles, and we need to deal with this. If we consider the following, theta is between negative and positive 180. So if we altered the interval, which is not essential, we could say that this is going to be between minus 60 and positive 60. So let's go ahead now and consider a principal value. So what we're looking for then is a principal value now of 1/3 theta. So if we think about now 1/3 theta, that is going to be equal to the inverse sine of 1/4. So in a calculator, in degrees mode, so if you're unsure, shift mode 3. We'll take now the inverse sine of 0.25 or 1/4. Principal value for 1/3 theta. So what we're going to have then is 1/3 theta is going to be equal now to 14.477 dot dot dot. So 14.47 dot 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 dot. Now let's consider the symmetry of the sine curve. We know that sine of x is equal to the sine of 180 minus x. So if I look at this right here, we could say now that 1/3 theta is going to be equal to 180 minus this 14.47, which I can of course store in my calculator if required. Subsequent solutions for this angle right here are going to be plus 360 degrees on from each of these. So if we look, we're only now interested in theta, 1/3 theta between minus 60 and 60. Clearly from here now, if I add or I say do 180 minus this quantity, that is going to be bigger than 60. Therefore, this one is not going to be in the interval. And by the same token, if I subtract multiples of 360, that will also not be in the interval. So all we have here is one solution. So what we can do is simply state that theta is going to be 3 times this quantity right here. So it's going to be 3 lots of 14.47 dot 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 dot. So let's look at that in a calculator. So we're going to have now, and again, if you're working with this, store it in as A. Let's go ahead. That's not right. Let's just get that again. So what did we have? We have the inverse sine of 0.25. Okay, that's for 14.47, and then if I multiply that by 3, we get 43.4. So let's write that in. So theta is going to be equal to 43.4 degrees. Okay, if we look at that now, what we're going to have, we can see from there, that's done to 1 decimal place. If we think about subsequent solutions to this equation now, we've got 1/3 theta. Therefore, this isn't going to cycle every 360 degrees, it's going to cycle every 1080 degrees. Remember, 3 theta would cycle every 120 degrees, therefore 1/3 is going to be 3 times the length of the 360. Okay, let's just see what we've done. We've solved now for the angle 1/3 theta. We considered this now 1/3 theta, and that was going to be equal now to the inverse sine. So let's just do this. What I've got here now, this is what we were originally doing. So we were only looking now for the following. We were interested now in the interval here from -60, so that's -90. We were looking at it just here to about just there. And the question is, where was this equal now to 1/4? Well, we can see from this that we've only got one solution, and that is going to be give or take around here. So this is what we can do. We can just put that on, and that gives us the one solution. And this is what we showed just here. So we can see that there aren't going to be any others. So that's our one solution. And as stated, lots of different approaches to finding it. But hopefully that's given you some idea. So there are a few more examples of solving these trig equations. In the next video, we'll go through some more examples, but hopefully you're now starting to build up the confidence to tackle when we have now what we call the multiple angles, and also now the combined angles. I'm looking for the word compound. That's what we want. Compound angles. The compound angles. So nice, good approaches and different methods. Don't be scared to use different methods. Consider all of the values in the given interval, and then go ahead and solve.